Welcome back to The Explainer. Okay, let's dive right into this. Have you ever looked inside a chemistry lab and felt like you were staring at the bridge of an alien spaceship? You know, all those weird glass tubes, strange metal stands, bubbling liquids? It can all seem incredibly intimidating. But today, our goal is to completely demystify the chemistry laboratory. We're going to break down the common laboratory apparatus and equipment so that by the end of this explainer, you'll feel right at home. So to kick things off, here's a highly practical question for you. How do you tell a good egg from a rotten one without actually cracking it? It's a great question, isn't it? And it perfectly illustrates the fundamental difference between just passively looking at something and making a deliberate actual observation. Science isn't just staring at the world, it's testing it. Well, the answer to our egg question is actually brilliantly simple. Step 1, grab a bowl of water. Step 2, put the egg in. Step 3, if it sinks to the bottom, it's good and fresh. If it floats on the top, it's rotten. I mean, nobody wants to accidentally bake a cake with a rotten egg. The smell alone is an absolute disaster. But this classic test is a perfect real-world example of using an experiment to make a careful observation. It shows us exactly how we can discover a hidden truth through a simple, controlled action. All right, here's our roadmap. We're going to cover 5 key areas today: the science of observation, inside the chemistry kitchen, meet your lab tools, why glass rules, and finally, lab safety. Let's break this whole complex room down into logical, manageable pieces. Section 1, the science of observation, using our 5 senses. You see, the very first step in science is simply noticing what happens around us using our 5 senses: our eyes, ears, nose, tongue, and skin. But we have to be careful, right? Because not all observations are created equal. A non-scientific observation just describes personal feelings and cannot be tested. Like saying, the sun looks magical at sunset. That's a beautiful thought, for sure, but it's totally subjective. A scientific observation, on the other hand, is a verifiable fact. The sun always rises in the east and sets in the west. That clearly defines the boundary between untestable feelings and concrete scientific reality. Because, let's face it, observing alone just isn't enough in science. We need a reliable system. To verify any scientific fact, we absolutely must follow these 3 crucial steps. Step 1, observe what's happening. Step 2, experiment to test that observation under controlled conditions. And step 3, conclude, which really just means clearly stating the truth you've discovered. That is the pathway from an initial thought to a proven scientific fact. Section 2. Inside the chemistry kitchen, preparing experiments. Now, what's really interesting about a lab is how it actually bridges the familiar with the complex. Think about your kitchen at home for a second. If you want to make chocolate milk without making a massive mess, you need specific tools, right? A saucepan to warm the milk, a spoon to mix in the cocoa powder, and a glass to drink from. Each item has a very special intended use. Well, the exact same logic applies to a laboratory. Instead of food, we're preparing experiments. And instead of spatulas and blenders, scientists use specialized apparatus to precisely mix, heat, and measure chemical substances. So let's formally define this space. A laboratory is basically a special room where experiments are performed using specific tools called apparatus. It's designed to be neat, clean, and highly organized, with shelves full of these specific tools dedicated entirely to studying substances safely and accurately. Let's take a rapid-fire tour of the key physical zones you'll find inside this room. First up, the working table. This is where the action happens, equipped with gas burners and sinks. Then you've got the reagent shelf, where properly labeled chemicals are carefully stored so we prevent any dangerous confusion. Next, look up and you'll find the exhaust fan, which is absolutely essential for pulling foul smells and harmful gases right out of the room. And finally, the balance room, a separate smoke and dust-free space dedicated strictly to weighing chemicals accurately. Section 3. Meet your lab tools. Categorizing tools by the specific jobs they do. Okay, we're going to categorize this massive list of lab tools, literally the utensils of our chemistry kitchen, by the specific jobs they do. First up are heating tools. We have the Bunsen burner, which uses gas as fuel, and the spirit lamp, which uses spirit. But notice the difference between the next two. A crucible is a small porcelain bowl with a matching lid designed for heating substances that require incredibly strong direct heat. Conversely, a water bath is used to heat substances indirectly, for when a direct open flame might be just too intense or dangerous. Next, we have our measuring tools, and precision is literally everything in science. The analytical balance is a highly sensitive metal instrument featuring a horizontal beam and pans used for measuring the exact weight of solid substances. Right next to it, the measuring cylinder, graded in milliliters, is your absolute go-to tool when you need to accurately measure the volume of liquids. But obviously, you can't just hold bubbling chemicals in your bare hands. No way. That's where our handling and support tools come in, to safely hold everything else during an experiment. The tripod stand provides a sturdy, three-legged base of support. The wire gauze, an iron mesh placed on top of the tripod, keeps glass apparatus stable and makes sure the heat spreads evenly. Tongs are those long, scissor-like metal tools used to pick up incredibly hot items, like that crucible we just mentioned. And of course, the test tube stand, usually made of wood or plastic, keeps those fragile glass tubes safely organized and completely upright. Section 4, Why Glass Rules, Holding Chemicals Safely. Now, you might have noticed a recurring theme in the materials we've been discussing when it comes to holding chemicals. Why do you think it is completely unsafe to use plastic containers for heating chemicals in a lab? Just take a second and think about what happens to a plastic water bottle if you leave it too close to a hot stove. It turns into a melty, toxic disaster, right? In the harsh, high-temperature environment of a chemistry lab, the physical properties of your materials absolutely dictate your safety. And that right there is exactly why most laboratory apparatus is made of glass. Glass has simply unparalleled qualities for scientific work. First, it's transparent, so scientists can clearly see the reactions happening inside. Second, it withstands high heat. Special types of glass, like Pyrex or Borosilicate, expand very little when heated, meaning they just do not crack or break even at extreme temperatures. Third, it's super easy to clean and doesn't stain. And finally, glass is relatively inert, meaning it does not react with most chemicals, which makes it perfectly safe to use. Section 5, Lab Safety, Practical Application. And this brilliantly illustrates the combined application of everything we've learned so far. What you're seeing here is a classic, perfectly safe heating setup. Notice how the Bunsen burner acts as the heat source at the very bottom. Above it, the iron tripod stand provides a super sturdy base. Resting right on that tripod is the wire gauze, which evenly distributes the flame's heat so the glass doesn't shatter. And finally, the glass beaker holding the liquid sits safely right on top. Every single piece of apparatus has a very specific role, all working together to perform the experiment safely. But listen, having the right physical setup, that's not enough. Human behavior is definitely the biggest factor in lab safety. We've distilled the extensive list of laboratory rules down to these absolute, most critical, life-saving takeaways. Always wear your lab coat. Only perform experiments under your teacher's guidance. Use small quantities of chemicals to keep reactions manageable. Absolutely never touch, taste, or inhale unknown substances. And finally, maintain silence and discipline, because a laboratory requires real focus. Actually, I want to draw some special attention to one specific rule here. Never, ever pour hot or strong acids directly into the sink. Always, always let water run into the sink first so that whatever you are disposing of gets safely diluted and washed away. I'm highlighting this because safety definitely doesn't end when the experiment is over. Careful safety protocols extend all the way through the cleanup process. So the whole point here is that doing science properly is really about methodical care. Consider this fact from our source material about the famous scientist Robert William Boyle. He was literally one of the first to write down his experiments correctly. He noted the specific apparatus used, the exact steps followed, and the clear observations made. This level of meticulous note-taking allowed other scientists to actually learn and repeat his work. It became the absolute gold standard for lab work that we still follow to this day. And that wraps up our explainer for today. But before you go, I want to leave you with this final, kind of provocative thought. How are you going to apply careful scientific observation to your everyday life? The specialized tools might stay inside the chemistry lab, sure, but the mindset of observing, experimenting, and concluding, that is a powerful lens you can carry with you everywhere. So the next time you notice something curious, don't just look. Observe like a scientist. Thanks for learning with me today.